Yesterday we have to discuss quantum mechanics, then wave nature of particles and de Broglie wave and Davison-German experiment and wave particle duality. Okay, so we discussed some of the important question yesterday class. So based upon this, we have to give some of the practice question. Okay, so இதெல்லாம் தான் லாஸ்ட் கிளாஸில் பார்த்தோம். ஓகே, ஸோ இதை பேஸ் பண்ணி தென் we have to give same 10 question okay for practice question. ஸோ நிறைய பேர் ட்ரை பண்ணியிருப்பீங்கன்னு நினைக்கிறேன். ஸோ அதுக்கான ஆன்சர்ஸ் இன்றைக்கி பார்த்துடலாம். ஓகே, then after that we move to the next topic. Okay, so then question number 1, then according to de Broglie hypothesis, the wavelength of moving particle is inversely proportional to, so that is the important. So in before classes directly proportional or question பார்த்தோம். So in practice question we have to give inversely proportional. Okay, about how to write then de Broglie wavelength, then lambda is equal to then h by p. Here h is the Planck's constant. So here p is the momentum. Here inversely proportional to, then lambda is directly proportional to h, that is Planck's constant. So இது முன்னாடி கொஸ்டினை நம்ம பார்த்தோம், one of the question yesterday we discussed. So here then wavelength is inversely proportional to momentum. Which one is correct? Option C is correct. Okay, so directly na Planck's constant h, then inversely na momentum. Okay, so sometimes problem kekkalam. Okay, so then lambda which is equal to then h by then momentum can be write it as mv. So h என்றது constant, mass என்றது constant, then velocity மட்டும் கொடுத்துட்டு then we have to find out the wavelength. Okay, so then question number 2, an electron is oscillated through a potential difference V. If the potential difference is increased by 4V, then what is the de Broglie wavelength became? So already நம்ம இதை solve பண்ணோம். Okay, so then de Broglie wavelength which is equal to what is here, the electron is oscillated above 1 by, that is then Planck's constant h by then momentum p, then h by, so then electron oscillated through potential difference now we have to get 2m ev. Okay, so the last class la நம்ம discuss பண்ணிருப்போம். Here where is that? Yes, here we see that the same one. So the same question based upon this one, then we have to give one of the problem. So here then lambda is equal to already number in the equation solve பண்ணிருக்கோம், that is the important one. So then lambda is equal to h by root 2 mev. So when electron is oscillated through the potential difference, then we have to get this one. Okay, so we have to use this one. Okay, so already number solve பண்ணதுனால I have to directly write the formula. Okay, here the potential difference is increased by 4. Here we take it lambda, then lambda dash which is equal to then h by root 2m e. Here potential difference is increased by 4v, 4v. Okay, then lambda dash which is equal to here, so which is lambda, lambda divided by root only 4 மட்டும் தான் இருக்கும். Okay, 4, then lambda dash equal to then root 4 எடுத்தா we have to get 2. Which one is correct? Option C is correct. Okay, so if potential difference is increased 4v na, the de Broglie wavelength became lambda by 2. So most important. So the next question, in Davison German experiment, then electron wave diffracted by then nickel crystal. So already we discussed from the previous classes. Okay, so if you consider this is the nickel crystal, so in that nickel crystal some of the photon of energy is incident, then we have to get diffraction or scattering occurred. Okay, so in Davison, an electron were diffracted by using nickel crystal. So then diffraction is one of the property of wave, so it conforms by Davison German experiment. Okay, the observation of electron diffraction in Davison German experiment demonstrate the, which one is it demonstrate then wave nature of electron. Okay, so already we have to discuss elaborately. So if two particles having same momentum, the de Broglie wavelength or so then de Broglie wavelength, then lambda is equal to h by p, then lambda dash equal to h by p, above which should be a same, but lambda which is equal to lambda dash above equal. Okay, option A is correct. Here for non-relativistic particle important, for relativistic வேற மாதிரி வரும், non-relativistic we have to get different. If its kinetic energy is increased by factor 4, then it de Broglie wavelength, so then de Broglie wavelength lambda is equal to h by root 2 mk. I have directly write the formula, so இதுமே நம்ம solve பண்ணிருக்கோம். You say that before that. You see that this one, so this one we have to take, so இந்த ஃபார்முலா தான் நம்ம எடுத்து அந்த ப்ராப்ளம் யூஸ் பண்ண போகிறோம். ஓகே, ஸோ லாஸ்ட் கிளாஸ்லேயே நம்ம டெரைவ் பண்ணியிருக்கோம், ஸோ இதை தான் நம்ம எடுத்திருக்கோம். ஓகே, அப்போ ஹியர் kinetic energy is increased by the factor 4, அப்போது then lambda dash then h by root 2m, kinetic energy 4, அப்போ 4k, அப்போ lambda dash which is equal to lambda wavelength, அப்போ by root 4, then lambda is equal to, then again we have to take root 4 then root 2, so option C is correct. Okay, then which phenomena provide direct experiment evidence for wave nature of electron? Which one is electron diffraction? So இதெல்லாமே முன்னாடி கொஸ்டின் நீங்கள் அண்டர்ஸ்டாண்ட் பண்ணியிருந்தீங்கன்னா the 7th question maybe we have to get the answer within the fraction of seconds. Okay, so then electron diffraction. An electron and proton have the same momentum, the de Broglie wavelength are also equal. Same question, this type of question. Question number 5. Okay, so if electron and momentum have same momentum means the de Broglie wavelength is also same. So because we know that then lambda is equal to h by p. Okay, upper here h by p can be write it as m, upper mass of the electron and mass of the proton, if it is same then de Broglie wavelength is also same, upper equal. Okay, then which of the following is a wave property exhibited by electron? Which one is this one is also simple one based upon the previous question. That should be diffraction. Electron charge சம்பந்தம் கிடையாது, spin counter number வராது. So then sometimes there may be a confused, but rest மோஸ்டும் கிடையாது. So the diffraction. Okay, so sometimes elimination method is also sometimes useful. Okay, so then last one, then wave particle duality means that, so already we have to discuss from the previous one also. So question, so option C is correct. Microscopically exhibit both wave and particle property. Okay.